Welcome back, Linux enthusiasts. In the last chapter, we talked about Linux history and its evolution. If you have not covered it, please go through this video and cover it up. I am Himanshu, and this is chapter 2 of Staragile's exclusive Linux learning series. Today we will be discussing about installation of Linux. By the end of this video, you will have a practical knowledge on how to install Linux OS. But before we dive into it, please make sure you subscribe to our channel and hit the notification bell so that you don't miss any of our upcoming episodes. In this video, we'll talk about the installation of Linux. We will see how to install an operating system called Linux and where to use it. So there are two ways. I am currently using my Mac, which is a ARM based processor. If you are using a Windows machine, you can use a software called VirtualBox. So VirtualBox is available. You can just Google it up. It will download the VirtualBox for you, whatever the platform that you are using. And then you need an ISO image, which is an image of an OS you would want to run on top of that virtual machine in the VirtualBox, and then you can install it easily. So I'll show the two ways to do that. I am using a software called Parallel Desktop, which is mainly for Mac, not for Windows users. But the people who are using Mac, they can use Parallel Desktop and easy to download and install it. So this is how the control center of Parallel Desktop look like. And if you look at here, I have deployed a lot of virtual machines already. Let's create a new virtual machine and install it and see how does it go. So you see there are two free systems showing to me for Ubuntu. One is Ubuntu Linux, another one is Ubuntu with Rosetta. The difference between this Ubuntu and Rosetta would be, Rosetta is nothing but it's mainly used for the Linux translator for the Mac OS which are running on the ARM system. So we talk about ARM. I'll just give a little brief of what ARM and what BSD and what other standards architectures are there. So ARM is the architecture which is different than typical x86 64 architecture. The reason being, it was developed somewhere around after later 2020 in order to perform a high CPU GPU kind of operations. They developed ARM based hardware. On top of it, they need a compatible support of softwares which will be running on top of that hardware. So Rosetta here basically plays a role where it translates if you would want to run an image which is not a ARM image, compatibility, not a direct compatible, but with the help of Rosetta, it can make a compatible on running on the ARM hardware. So if you look at like this, we can explain that this is the hardware machine. We have it, but the hardware machine is a ARM based machine, and your OS, the typical you are using is, let's say, x86 64 architecture. It is not directly supported on the ARM machine, but what does Rosetta do is it creates a layer in between, which basically uses for the transition of data, or I could say how to manipulate that instructions that you are passing up from the OS to hardware. So with the help of that, let's say the OS is not ARM directly supported, but with the help of Rosetta, it can communicate to the hardware, which is a ARM based hardware. So that's a play major role for the Rosetta. So here we see that there are two options. One is just the Linux and another one is Rosetta. We will go with the Linux one. Rosetta one, you can use it, but it takes a lot of other storage of yours, because it requires certain other applications or softwares to be deployed. So if you're using a SQL server, or let's say if you're using any of the software which are not there for the M1 M2 chips, then you can use the Rosetta one. Okay, so let's click on download Ubuntu Linux and then click on continue. So the current version of Ubuntu is showing 24.04, which is the ARM 64 support package. The current size of the package is 3.3 gigs, and if you unpack it, it will be 7.62 gigs. So we just download the package and then see. So it will take a while, it will take a while, somewhere around 5 to 10 minutes, depending on your internet that you are using. And after that, it will build a OS for you. Since I have already built the OS, I have already installed it. You could see something like this coming up. So I'll minimize it and show the brief. So this is the Ubuntu. that I have downloaded and installed with the help of Parallel Desktop. This is how the UI look like. You can see there are icons in the left side. There is a task, there is a bar here. You can search whatever you would want to search. So let's say if you say, any browser, Firefox, so it search the Firefox and open it for you, and you can do whatever you would want to. Similarly, for the terminals, you can search the terminal and then you can open the terminal window and then you can perform actions. So similarly, there are a lot of files. If you want to see the files, like how we see folders in Windows, this is how you can see that. So there are files, home directory, documents, downloads, music and stuff. So this is the download folder. It has these files, and there are other files which are default and I've created manually. So this is how the UI look like of Ubuntu. If you want to see which version of Ubuntu I'm using, you can just there is a file which stores that information. The file location is etc lsb releases. So this is the file which stores that information, which version of Ubuntu I'm using. So if you want to read the content of the file, that we are going to talk about in the next chapters, in the commands that we will be discussing, that's where we will see how to read and write and execute the files. So you see this, I'm using the same version, Ubuntu 24.04, which is LTS. The normal one also is available, which is not a long time support. So that is fine, depending on the use case, whatever you would want to use. So the distribution for this is 24.04. Yep. So that is one way of using it. Another way we will discuss here. Meanwhile, it will complete the download and then create a new OS for me. Let's open the VirtualBox. VirtualBox, you can download the VirtualBox software from here, the VirtualBox official website. And you need ISO image also, so you can download the ISO image from the ubuntu.com itself. The latest version if you want to go with, or the lower version you can go depending on your choices. Yeah, so then I have downloaded the latest version, which is the Ubuntu 24.04 LTS, and I have kept it myself. Now in the VirtualBox manager, which is, this software is freely available for people who are using Windows machine or any other machine. So you can just click on machine, build a new machine. You can name it like, say, Ubuntu Staragile, and then the folder where you would want to store this ISO image, you can just select ISO image. Since I have already downloaded the ISO for Ubuntu, which is a Plexi desktop, ARM supported ISO, and it automatically detects that which type of OS that you have selected, which is the Linux, what is the subtype, which is the Ubuntu, and what is the version of it. It supports the ARM based processors, and you can just choose here. So seems like this hostname is not available. It does not accept the underscores. You can just remove the underscore and then take it forward. So once you finish it up, you can see the virtual machine will start rolling up. There were a lot of processes which will start downloading and then not downloading. It will start installing. So once we click on try or install software, it will install the library of the kernel and then other application software which are needed for this OS. It will also take somewhere around 5 to 10 minutes to, download and then set it up the machine. And here in the PPT you can see this is how you use it. So once you set up this virtual machine, this is how it looks like. I wanted to showcase for the rel. That's how for rel you see the machine folder rel 8 here, and then this is how once the virtual machine is ready to use, it'll be in the power off mode. You can just start whenever you would want to start. So yeah, finally we can see that the Ubuntu Staragile machine which we deployed in VirtualBox is ready to use. You want to type it and search terminal. Let's say it opens up the terminal for you. Now it depends on the storage that you are giving and the CPU you are giving for your virtual machine, how much data it requires in order to run it. So sometimes people have very less architecture, they have very limited storage available on their machine, and if you would want to create a virtual machine on top of it, might be you can face the slowness over there. So depending on the storage, depending on the CPU compute power, depending on the memory that you're assigning to your virtual machine, the performance of the virtual machine will improvise accordingly. Since I am using a Mac M2, I have 500 gigs, uh, storage, and then 16 gigs memory. So it's enough storage and enough memory to use. With the compute power of two CPUs, I'm standalone using for this virtual machine. That's why it's quite kind of giving a quite nice response to me, including in parallel desktop and virtual machine, VirtualBox both. So we'll just close this up. And if you look at here also, the same file is present. Yep. And if you want to see the content of it, you can see this is a 25.04, which is the Plexi version, little ahead than 24.04, which we saw for parallel desktop. So this is the one which I downloaded. They called up Ubuntu Plexi Puffin, and this is a development branch of it, which means that still the community is developing this branch. It's not yet merged with the main branch, which means the main package of software which is going to deploy later. So this is just a testing version of it, which I've downloaded and I'm using and showing it to you guys. So that's how it look like. Yeah, it will take another 2 to 4 minutes to complete it. So that's how it is actually. So it's about the compatibility. Let's say somebody who is using Mac OS, best to go with the parallel desktop and then download an image automatically from there with the help of internet, and then you can install it so quick and easy. And if you are a Windows user or any other OS user, you can download VirtualBox or VM Workstation. There are a lot of softwares available where you can download the ISO image, and then based on your compatible hardware, you can deploy and install the Linux. It's easy to install and use it. So that's about the installation part that we have covered so far. So let's talk about Linux file system hierarchy. As you can see in the slides, there are various type of files which are available. So I would want to explain it like this. In Linux file system hierarchy, the top level directory, which is called / is nothing but a root directory. We call it a root directory. This directory is nothing but a folder. In Windows, you can think like this, but in Linux, everything is a file. There is no folder, there is no directory kind of a concept, but there are types of files which are available in Linux. For example, a folder treats as a directory type file. A normal text file treats as a normal text file, it's just a file. So this / is nothing but a folder. We call it a root directory. Then there are a lot of branches, which means there are a lot of other directories present inside this root directory. For example, bin, mnt, etc, media, proc, lib, dev, and etc. For example, temp, usr, and stuff. So, and boot, that's very important directory. So every directory inside the root directory contains few files, lot of files sometimes, but depending on the softwares that they are basically leverage and use it. So all the binary executables which are present on the Linux systems are present in the /bin directory. So we name it like this, /bin. That is a path of that bin directory where all the binary files will be present and inside this. /mnt is basically used for mounting. So let's say if you are having any temporary devices, let's say USB drives or CD drives, hard drives, you can connect to the machine and then it will be showing up in the mnt for the temporary purpose. Then temp file is another directory where whenever any process runs and if it requires any short for temporary purpose storage, then it stores in the temporary directory. etc basically all the configurations for all the servers it uses under the etc. So etc is very important directory where all the configuration files are being stored. Similarly, usr also has further architecture like USR, then USR lib, then USR sbin, you know. So this also contains libraries, and this also contains some of the binaries. Then media is another one. Default any media type of file which is there by systems, so it by default stores in the media directory. You can also store anything in the media directory depending. Boot directory is very important because it contains the kernel of Linux, and it contains the process how does the Linux boot. Basically, boot means when we install the Linux, after that when we turn on the machine, the process by which it follows, and then it opens up a UI or CLI for us, that's called a boot process. So boot process has to be come from the hardware side, BIOS, and then after that, there are processes which are being used. So, and kernel also, it loads the kernel. The first process itself is the init process, which is a kernel process. Kernel process and files are present under the boot directory. We will see this in the demo as well. Then proc basically contains information of your CPU or of your memories. So this is the proc directory. Then there are other directories called library, which also stores library file types of files. Then all the devices, let's say your hard drive, your NIC card, or your exact another USB devices, those are the devices are being stored by default in the dev directories. So it's a device type file storage. Similarly, there are other as well. SRV is there. SRV, which is a virtual file system providing information about the devices and the kernel modules. Then there is something called run as well. So what runs is it stores the runtime process IDs. So whenever any process runs on the Linux machine, the process ID for that process is stored in the run directory. Then root is another one that is also important. So in Linux, there is a user called root user. The root users directory is a root directory, which is a /root. If you look at the path of it, it's a /root. We will talk about what path is, what type of paths are available, and how do you see that structure and directories of it. So let's see the demo part of it. Let's do hands-on on the Ubuntu machine that we have installed and downloaded it. So we will see that. So let's go to the / which is a root directory that we have already spoken, and the / and if you want to see the directories and the files which are being stored on the /, you can see there is a command called ls command. We will talk about those commands on a bit later. So I'm just trying to show you what are the directories and the files are being present. So we have seen bin, which is a binary types of files which contains the binary files. Then root is there, then dev is there, etc is there, home is there, mnt is there. So let's review what is there in /boot. So you see it contains the image of your kernel. So VM lineage is nothing but the kernel image which is being deployed when we start the machine. Init rd, this is the RAM which it uses during the process of initialization, and VM lineage. And the grub is nothing but a bootloader. So bootloader means with the help of bootloader only any operating system can boot. So those files are present under /boot /grub. So if you look at grub, you will see the grub. The important file for the grub is bootloader is grub.cfg. So if we want to read any content of a file, we can run cat command that we are going to discuss later in our session. So currently I am getting permission denied because I am not running this with the root user, but when I run it with the root user, you can see this is the file. So the grub.config is this file, which is a typical Linux file. How does it look like, the configuration file? And here it explains about the Ubuntu, what is the Linux version of Ubuntu kernel, which is a 6.8 here, and what is the class, it's a GNU Linux basically, and then the setup mode, it is telling what is the root mode it should set up for, and then stuff. So this is how the file look like here. So let's check another file called etc. So as I told, that etc directory contains all the configuration types files. For example, I am looking for the configuration of Apache web servers. So that's stored in etc Apache, Apache 2, and then Apache 2 config. So that is a configuration file for any of the softwares that you would want to deploy it in Linux. So everything you will find it in the etc directory. Here you can see this is the configuration of that Apache file look like. Now let's look at /bin. So all the binary executable files are usually present in the binary folder. You can see there are a lot of files which are present. These are nothing but a command which basically we use it for the Linux, and this command is nothing but a file which is executable file. We are going to talk about in the permissions what is executable file, but yeah, this is a file, kind of a command which are being stored in the bin or sbin directories. Similarly, sbin also has few of it. Yeah. Then let's talk about /mnt. Currently there is nothing because I have not mounted any of the USB drive or any other drives, so it's empty. Now let's talk about SRV. If we have any web servers, currently there is no configuration file because we have not deployed any web servers data in the SRV files. And if we see run, then in the run, currently there is no process going on, but usually the process which are running, you see the process IDs are being stored. Let's say if I see SSH is the process which is running, and I would want to read this file. So this is the process ID of SSH which is stored under the sshd.pid file, which is stored under the /run directory. Similarly, for other processes like let's say Apache 2 or cron process or cups process or DNS mask. So these are nothing but applications that I've deployed so far on this machine, and the processes which can be used or seen here, PSAUX, we'll talk about that in process management. So those process IDs are being basically stored in the /run folders. So you can just make a note of it that /run usually contains the process ID for the various processes. Alright, so let's see what it is in the root directory. Currently I'm getting a permission denied error which is expected behavior, because any normal user who would want to open the home directory of a root user or any other user, you'll get the permission denied errors. So currently I'm logged in with the parallel user, which is the default user. When you download and install the Ubuntu machine on the parallel desktop software, it creates a user called parallels by default, and then I'm unable to open the root home directory of root user. But in order to open it, I can do sudo and then open it. Sudo ls/root. So now I see there is only one file which is present in the /root directory. Similarly, let's see what is there in my home directory. So these are the file present in my home directory. This is in the / which is the root directory, but if I want to see for my user, so it will be under /home/parallels. So any user you are going to create in this Linux machine will be stored under /home directory. So home is nothing but you can think like the structure under which the configuration file for any users are being stored. So for parallels user also, we have configuration files, and all important files or whatever the files manually created will be present under /home directory. So it contains the home configuration for any users. So I can see desktop downloads and whatever softwares or directories that I have created so far, you can see all of it here. Similarly, if I see let's /dev, so all the devices that we are using, currently we are using this shell. Shell is nothing but a software itself which runs on top of terminals, TTYs. So those are the types of files, or device files or hard disk, I would say, which we can see by this command fdisk-l. So this hard disk informations are being stored under /dev. So all of these files are being stored under /dev directories. So that's why /dev are typically being used for all device types of files. Basically, the devices that we are using on our machine. So any external devices or hardwares or etc. So and then there is one more directory called /var. /var directory is basically used for logging purpose. There is a internal directory for /var is /log, which stores the logs for all the applications that you are going to perform, or any application that is not working on your Linux machine, let's say for example Apache 2 or SSH. So any of the application which are breaking, if you want to troubleshoot that and you seek for the logs for it, then you can look for /var/log and then respective directory for the logs. That's that's about the file hierarchy of Linux. It starts with the root, which is the root directory. Home directory for root user is /root, which we'll be talking in the coming up episodes. And then there are dev, there is a mnt, there is a spin, there is a bin/var. So there are a lot of directories. That's how Linux, talks. That's how the Linux file system hierarchy stores the files under, which is not typically present in the Windows or any other operating systems. Systems which are being used, or based on Linux platform, they have such kind of architecture. I would say Mac also has such kind of architecture, but there's a here and there a little bit of a difference you will find in the file systems, the present of whatever the working directories and stuff. So yeah, that's typically about file system hierarchy in Linux. Let's talk about file system characteristics. Here we'll be discussing about what Linux and what type of files which it has it, and then how do we traverse from one directory to another directory, and how do we create files, and what are the files that are being present. So we'll discuss all this here in this. Now there are several types of files you can see in the PPT, which are nothing but block type files, socket files, character files, directory type files, text files, links files, and pipe files. So we'll discuss each of it, how to create those files and how to see what type of a file Linux has it. So let's see here. Let's talk about the block type of files. So basically, to create a block files, you can use command called sudo. Sudo is for the super user power. We'll talk later. There's a command called mknode, which basically creates the block type of files. And I'm just using this command, and I'll tell you what this command explains. So this has created, let me create, this is mkd. I have created a directory. I'll create mknode. So this is already exists. Let's create block 1. And let's describe this. So ls command is basically being used to describe any type of files or directory present in the Linux systems. So now let's see this, what it explains. I'll zoom a little bit, and here you can see the first value of the permission here is a B. B stands for the block type of files, and we'll explain what this is in the permission section. The main thing we are going to discuss here is that this is the directory that we have created. It's nothing but a directory. It's a block type of file. B stands for the block type of file. 8 is a major number and 0 is a minor number here. So what is a major number basically? So major number is the device number, how a device being identified. For example, any device which is a SATA and CSI based block type of devices, those are the devices which are being numbered as a number 8. You can see there are different type of block devices. If let's say we check the entire dev and we see the block, let's find actually /dev -type block. So this command will give us these are the block type of files which are present currently on my system. So all of them has B in the starting of the permissions, which means it's a block files. You can see the major number differences. There are few which are 7, there is some which are 8, there is one file which is 11. So the major number difference is there because each device inside that block type of files as identified as a number, and it's a device number basically. So let's say if we talk about SATA drivers and devices, those are being identified with the different numbers, and uh, you know uh, the SCSI and SATA things which are defined by the 8 numbers. So these is the numbers, major number which are being used, and there is something called minor number that we used here, which was 0 in our case. So 0 defines the minor number. Minor number basically is being used to represent the specific version or device partition. So in the device, you would want to see which partition it uses. So that minor number tells about it, and major number about the device number. So in order to see, it can also vary. Basically, some numbers has 1, some numbers has 0. So a difference between this is because of instances and the partitions that are being used in the devices. Okay, so that is a device type, that's a block type of file. Now let's talk about socket type of files. So socket files are basically, we would see in the networking phase when there is a service which is running, and we open a socket in order to communicate to something. Let's say, for example, you want to communicate to google.com, right? So you have opened google.com website on your local machine, but that socket is needed in order to make a communication, in order to make a connection to the Google server. So at the Google server also socket is required. That socket is nothing but a socket file. In terms of Linux, I'm explaining the socket file, which is basically used in order to communicate, establish the connection between two parties here. So client and a server. So that socket files are mainly being used for the communication, for the networking things. How to see what type of files are being socket files? So usually the character called C is stands for the socket. Sorry, S stands for the socket. And let's see what are the files that we see here. If I find hyphen type socket, so we see these are the files which are socket files. And if you want to see the characteristics of this, so all of them has a S at the starting of these files. That is a socket. S stands for socket. So you can see this here in my local directory, home parallels, home directory. There are a lot of there's a lot of cache which are being used, and those are the open sockets which currently is available on my system. Similarly, for systemd, systemd is also a Linux process which also requires a socket to be open in order to communicate, not to the server but in order to communicate to the hardware. It's a middleman, right? A kernel is a middleman, so it requires a socket in order to connect. Similarly, there are other socket files also. In temp also there are some, you can see, which are hidden files but represents the socket. So this x11 is nothing but a graphical representation of our UI. So that's what x11 stands here. So those files are also socket files. It requires a socket to be open. So that is a socket type of files. Now let's talk about character files. So basically character files are being used for devices, let's say keyboard, mouse, or terminals where this shell is running. So those are the files which are being called as a character type of files. And how do you see that character type of files is? You can just find it with the help of find command. Type character, where you would want to find /-c dev null. I will explain this command later in the command section, what I am doing currently, but I am just showing to you how to find character type files. So you see all these files are basically the character files. So the major things which is easily understandable is the terminal files. See, this is the terminal where I am currently running my shell. So this terminal file tty is nothing but a character type files. Or if you look at here, pts, some sg, there are some input files, media files. These are all kind of character files. So let's create a character file. If you have this question, how to create a character file, so we can create the same mknode command that we use to create the block type of files. Sudo mknode, let's say device my character, and type is character type files. It also requires a major and a minor number. And let's explore this and see. This is a character type file which I have created just now. Timestamp, you can see it matches, and then it has a major number, it has a minor number. So in the terms of character files, the major number basically used by the kernel to map the specific driver, this number here 240, and 0 the minor number here, which is used to identify a particular device or instance for a device. So that's a minor number. So that is how you can see, you can identify the character type files. Let's talk about FIFO type of files, which is another type of files which are present on the Linux systems. So let's find those type of files here. FIFO, nothing but a pipe. So we stands with a P, and so you can see this. These are pipe files, and then these are files you can see in the run directory or in the home directory. I have created already a my pipe. We will see how to create a pipe type of file. So basically, what is a pipe actually? So if we talk about this, right? So pipe is nothing but, you take the outcome of a command and then you pass it up to the another command, or it's kind of a short-term storage. You can think like this. You don't want to store somewhere in your hard drive, but you want to have a particular content, you're passing it through a pipe. The pipe holds it until you would want to consume it, and then you can consume it with the help of commands which can fetch the data from the pipe. So pipe is nothing but it uses for the inter-process communication in the Linux, but it's majorly used for the data which should not require any permanent storage. For a temporary storage, you can use pipe type files. So let's see how to create a pipe type file. So there is a command called mkfifo which creates pipe. So I've already created my pipe. I'll create one more, my pipe 1. It requires sudo, so I've created it. Okay, so you can see this here, pipe type file which is called my pipe 1 has created already, and you would want to send the data to this. So how can you do this is sudo echo, let's say I say hello from Staragile, and then sends it to my pipe. Okay, so there is a permission error because I am doing the changes in the slash directory, which is nothing but not allowed for the normal user to access. So I'll just go back to my home directory, and that's where I'll create a new pipe, and then we'll do the operations on top of it. mkfifo my pipe 1, and let's do this, echo hello from Staragile, my pipe 1. So now currently the data has been sent to the pipe. I am not seeing anything on the terminal, reason being the pipe is not yet consumed. So until we consume the pipe, the data will be there for a short-term period in the pipe itself. So in order to consume it, let's create another terminal in the new window, and then we are going to use that pipe. Let me just increase the font size. Okay, so if you want to read the content, first you need to see the pipe is created here. Okay, I have the pipe, my pipe 1. I want to read the content from my pipe. So you can see hello from Staragile, I can read it. So that's how the pipe is being used, and now this terminal, this session has closed automatically. The reason being the pipe is already consumed. So you can see here the my pipe, basically the pipe type of files are being used for the processes which requires the data to be stored for a temporary purpose, not for the permanent purpose. And once it is done, you can consume whenever you would want to consume. Until that, the pipe will be in hold state, and then once you consume the pipe, you will be able to retrieve or fetch the data from the pipe itself. So that's a usage of pipe type files, nothing but called FIFO files. Yeah, so that's it. Let's talk about socket type of files. Yeah, we have already talked about socket files and character files. Let's talk about regular files and directories. So if you see here, all the directory files are being represented as a D, which is called a directory. Directory means it's a folder. So in order to create a directory, you can use command mkdir. I'll say test. So, and when I see the type of directory, so the test directory is nothing but a D, which is the directory type files. A regular file we can use to create touch command. Let's say I say sample file.txt, and if you look at the permissions of this sample file, you see there is the dash here. So this dash represents that it's a text file, it's a normal file, it's a regular file. It's not of any of the type, it's just a file type which Linux uses. So yeah, so we have talked about pipe type files, socket files, then we have talked about character files, then we have talked about directory files, then we have talked about block files and regular files. Yeah, and there is symbolic links or symlink files, link files basically. Link files are being used to link a particular file to a different file. That's what the usage of a link is being used. So in Windows, you might have seen we call it as shortcuts, basically being created on the desktop itself. Let's say you have downloaded and installed a game. So the shortcut icon of that game is being displayed on the desktop. That is nothing but a link type of files. You are linking original file to a copy of it, and you can access that original contents via that copy itself. So that's what called links type of files. There are two type of links which are present in Linux. One is soft link and one is hard link. If we see the differences between and how to create is, so you get the differences here, that soft links are basically being, so there is a command called ln which are being used for creating the links. For soft links, the syntax is ln-s and then target to which file you would want to create a link of. So let's say if I have any file example.txt, I'll create example softlink.txt. Okay, now if you see the example softlink.txt, you see this file is a link type file because L represents a link. But the difference is how will you identify to a soft and hard is, I'll tell in a bit. You can see this file which I have created is it's pointing to the original file. So the original file is a example.txt and example_soft_link.txt is the soft link of that example file. There is one difference you can see here is when you see ls-i, so you can see the inode number. Inode number are the unique numbers which are stored in the Linux file system. With whatever format we format our hard drives, usually if we talk about in Windows, we format it with the FAT32, FAT64, NTFS formats, right? In Linux, there is ext2, ext3, ext4 are the older versions. Then XFS is the latest version, and there are other four versions or other versions are available of the file formats. So those formats have certain type of inode numbers, the numbers which represents any specific or particular files. So any file in Linux system has a particular number. So there are chances, the usage of inode number is what I'm explaining. There are chances that your hard drive has the storage available, but you are still unable to create any content inside it. Reason being, if all the inode numbers are being consumed. So that could be one corner scenarios. So here we can see that inode number is different for both. So it's a unique representation of number which holds or which points to a particular file or a directory or any other type of files, right? So this file, link file, has inode number ending with 646 and the original file has inode number ending with 334. So the difference of inode number is present here. Now let's create a hard link file. Let's say example.txt. hardlink.txt. Okay, already exists. We'll create one more. Okay, now let's see inode number. The inode number for the hard link is 334, and if you see the representation of this, how it differs with the soft and hard. So you see this is a hard link, and when we see this ls-l soft link, we see there is a redirection or there is a point of that soft link to the original file, but in case of hard link there is no pointing such that. And you see the difference here. The hard link has the same inode number of the original file. Now what it explains is, if you delete the original file also, that hard link file, the link that you have created, will still survive and it still has the content of data. So that's the usage of links here. So hard link is basically good in order to store the data that you would want, not to lose, but soft link basically loses out the data. So it's basically broken once you delete the original file, but in case of hard link it is not actually. So, and if we talk about further differences is, so the link type is different, that we have already seen. The directories, so for in case of soft link, you can link the directories to the file and directory both, but you cannot link the directories in case of hard link. So let's say if we try to create a directory, let's say mkdir test, or let's say one more, and I want to create a hard link of this test1 underscore hard link. So it says that hard link not allowed for directory. Let's try to create soft link test1, but soft link is easily created. So that is a difference in terms of directory creation. And if you look at this test soft link, you will see this directory is basically representing or pointing to the original directory, which is a test1 in this case. And in terms of performance, if we talk about, so for soft link it's basically a little slower. The reason being it uses the path resolutions for the original file and the shortcut files, but since hard link represents the same inode number, whenever any process which requires the fetching of that hard link file, it can directly go to that particular inode block and then fetch the data. So that's why it is more efficient and more powerful and more in terms of performance wise. So that's why it is being used. And if we talk about the cross file systems, then for soft links you can span different file systems or partitions, but in terms of hard links you cannot span different file systems and partitions. So that is a major differences between soft links and hard links. So there is a limitations as well. So when we talk about hard links which are not suitable for directories, that is fine. So if your use case is something which you would not want directory to be create a link of, but you would want a data to be persistent even if the original directory or the content has deleted, you can still access it, then it's good to go with the hard links. Otherwise soft link is a better solutions. So yeah, that's about the file types which are present in the Linux 7 type of files.
If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.